Okay, so eventually we're going to we're going to get to the point where we're going to talk about these operations as well. We're kind of talking about that. And it's not that difficult. In fact, every time we see this, we're going to go ahead and rewrite it like that. All right, you're just doing two of these now. All these examples right here, you're just going to do two of them, and you'll either add the numbers you get, or you'll subtract them, multiply them, divide them, whatever it's asking you to do. So let's go ahead and come down here and look at this. Now, it's a little bit different than what we talked about on that first day, because we're getting all these values off this graph. So kind of follow me here. If I'm doing f of 3 and looking over here at this graph, make sure you know f of x is the parabola, g of x is the other graph. I'm not sure what to call that exactly. But so if it's f of 3, I'm going to go to the x value of 3 right here on the graph. I'll go up to where it's hitting the parabola. That y value is 5. So f of 3 is 5. G of 3, so now I'm looking at this one. Same thing. Here I am at where x is 3. I would go up till it hits that g of x. That y value is 4. So on the first day, whenever we did this, we were plugging 3 into an equation and getting the output. Now we're just looking at the graph. It's the same thing. So now f of negative 2, I would come over here. Right there at negative 2, 0 is where the parabola is crossing the x-axis. So f of negative 2 would be 0. G of negative 2, and go up until it hits g of x. That y value would be 2. F of 1 is negative 3. G of 1 is 4. Okay. I want you to find the rest of those. If you're struggling on what it is you need to look at, raise your hand so I can come around and maybe try to explain it a little bit different. I did it right. Both my 8A classes, I did make a mistake on these, so make sure that don't just blindly write down what I wrote down. Alright, so there are all of those. Any questions on finding that from a graph? Alright, awesome. So let's go to these that have operations on it. So if I have f plus g of 3, again, I think it's a little bit easier to read it like this, to the point where this is how I would write it. Now you can refer back up to all this, all of the ones we just did off the graph, which is why we did it. F of 3 is 5. G of 3 was 4. 5 plus 4 is 9. That's your answer. So that's all you're having to do. I would rewrite it again like this. Find the values that those equal, and then do whatever operation it's asking you to do. So if you think you got a hand on that, go ahead and do the subtraction, multiplication, division. On D, it says B down there. That should be G. Going on to this next part. So we're going to use composite functions. Okay, it's kind of what this is called. So given two functions, f and g, the composite function denoted by f, it's got that circle. I'm always going to rewrite it differently. Okay, in fact, it's up there. It's in that box. I am always going to rewrite it like that. F composed with g is defined by, and then it explains through that right there. So we're going to 2a. So I've got f composed with g of 1, or of negative 1. Again, I am always going to write it like that. F of g of 1. Sorry, of negative 1. Alright, so this is different than what we just did. Up at top, we were adding, subtracting, multiplying, dividing. What this is going to do is we're going to work from the inside out. So the first thing we're going to do is g of negative 1. We're going to figure out what that equals. And then we're going to plug that into f of x. Now, we're still referring back up to the top. So look up at all those values we found. G of negative 1 was what? What was it? 3. So if g of negative 1 was 3, I can now write that as f of 3, and f of 3 equals what? 5. So you're just referring back up to all those values that we did, that we found off the graph. This one's already written, at least the way I like it. Again, I'm going to start from the inside out, or I'm going to work from the inside out. F of negative 3 is what? 5. So I'm taking all of this right here out, and because I know f of 3 equals 5, and I'm putting that in there. And we said that g of 5 was what? 3. We're going to use two new functions on 3. F of x is x minus 3. G of x is x squared. It says find the composite function. So we're taking two functions. We're going to put one in for x into the other one. It's the same process we've done before. It's just previously we put numbers in for x. Okay? So I'm going to do f of g of x. Now, looking at those two equations they gave us, g of x is what? X squared. So one way that helps some people is I'm going to do f of x squared. So now whenever I'm doing this, instead of having that x right there, I'm going to take it out, and I'm going to put x squared in. And now if you were to write your final answer, if you could simplify it, you would. This one you can't. So you would want to write the f of g of x equals in your answer. Going over here to B, and I'm going to write it like that. So looking at the instructions on this problem, f of x is what? X minus 3. So if it's easier to read it as this, I'm going to do g of x minus 3. So g of x, I've got that x right there. I'm going to take it out. I'm going to put x minus 3 in for x right there. Now, let's look at this. If I have x minus 3 squared, how many x minus 3's do I have? Because we'll need to simplify this for answer. 2. So anytime you have this, and again, you'll need your answer in the most simplified form. Anytime you hear me say expand your exponent, what I am telling you to do is list out, okay, get rid of the exponent and just list them all out. If I'm multiplying those two things, what is that process called? Does anyone remember that? Multiplying two binomials. Do what? Well, we're squaring them. I'll go first. So x times x is x squared. Outer, x times negative 3. Inner, negative 3 times x. Last, negative 3 times negative 3. So that would tell me that g of f of x is x squared minus 6x plus 9. Okay. Going to the inverse composition rule. So you've got two equations. It's going to tell us to either do f of g of x or g of f of x. In this case, we're going to do both. And I didn't say this previously. I should have. So let me scroll back up to it. If you're doing f of g of x, so you're plugging an equation into another equation. On both of those, our answers were equations because we never substitute a number in for x. If you're actually doing a number in for x, your answer is always going to be a number. So if you do f of g of x or g of f of x, so you're doing one equation to the other, and all you get is x. Okay, f of g of x equals x. That means that those two equations are inverses of each other, or opposites of each other. We talked about inverses either last class or the day before, or class before. The one where they reflect over the y equals x line, you switch x and y in the table, all that fun stuff. Alright? So if you were asked to use composition to verify that two equations were inverses of each other, you could do that by using the composition. So here's my f of x and g of x. And here I'm doing f of g of x. Am I going to work from the inside out or the outside in? I've already said it about 3 or 4 times this class period. Inside out. So I want to see what this is in here. In this problem, what is g of x? 3x minus 1. So instead of looking at it as f of g of x, I could look at it as f of 3x minus 1. The f tells me to go to f of x and to plug in 3x minus 1 into that x. Okay? So up here in red is what I'm putting in for x. So whenever you're asked to check if these are inverses or prove that they are inverses, once you do this, what you're really looking for is Does anything cancel? You're looking for all the numbers to cancel out, and that way you just get x. So does anything on this cancel out on this problem? Right now.
Wouldn't the 3 cancel?
Not first. What's going to cancel out first? The 1s. -1 plus 1. And then, what's going to cancel out? The 3's, because I would have 3x over 3. And because f of g of x equals x, that means that they are inverses of each other. So now going over to g of f of x. Again, I'm going to start from the inside out. So I'm going to write this as g of x plus 1 over 3. So that is going to be 3 times x plus 1 over 3. All that is in place of x minus 1. So currently, the way it looks right now, does anything cancel? The 3's right now. I'm multiplying something by 3 that I'm dividing by 3. Right? If I multiply 9 by 3, I get 27. And then if I divide 27 by 3, I'm right back at 9. So I did nothing. I went in a circle. Okay? So I would do that. After that, I end up with x plus 1 minus 1. So my 1's cancel. So I then get g of f of x equals x. In a problem, whenever you're asked to do this, you do not have to do both f of g of x and g of f of x. If one comes out to just x, the other one is going to come out to just x. Okay? So let's go down to the practice problems. I'm actually going to walk you through one right here. If we have time, I'll look at another one on the other page because they mix up a little bit. So these are just your operations, but they're a little bit different than the ones we looked at, because at the beginning, the ones we were looking at, we got off of a graph. Some people think this way's easier, some people think the graph's easier. Fortunately, I don't think either one is too difficult. So remember, g times h of 1, that means we're going to find g of 1, and we're going to multiply it by h of 1. I kind of want to look at these because there's some situations in here where I've seen mistakes in the past. So if I'm doing g of 1, I'm going to plug 1 in for n up here in g of n. Now, I've got two n's. So which n do I plug 1 in for? Both of them. Right? I've had some people in the past where they would look at that and, well, this is just n, so I'm just going to put that there, and somehow, I don't know what they do with that exactly. So g of 1, I've got n squared, so now that is 1 squared, plus 4 plus 2n, which is now 2 times 1. This math, it shouldn't be too difficult. 1 squared is what? 1. 4 is by itself, so that's easy. 2 times 1 is 2. 1 plus 4 plus 2 is 7. I would then need to do h of 1. So I've got negative 3 times 1 plus 2. That's going to give me negative 3 plus 2, which is negative 1. And 7 times negative 1 is what? Negative 7.